Hello, this is Mrs. Scarple, and in this video we are going to find roots of cubic functions. So we have this cubic function, x cubed minus 3x squared minus 10x. And we're going to use the graph that has been given to us to identify our roots. As you recall from the roots of quadratic functions, x-intercepts indicate roots of a function. And with this particular graph, I can identify exact x-intercepts. So my roots are x equals -2, x equals 0, and x equals 5. So I have my three specific roots. I have a cubic function. The fundamental theorem of algebra says a function of degree n has n roots. So this is a third degree or a degree 3 polynomial, and we have 1, 2, 3 roots. Now if I wanted to write my function in factored form, all I need to do is take my roots and use the opposite value in my factors. So I'm going to start with the x equals 0. X equals 0 can be written as x minus 0. When it's -2, we would write it as x plus 2. And when it is 5, we would write it as x minus 5. Now the reason I started with the 0 is because the value of x minus 0 is just x. And this would be the factored form of our function. So g of x equals x times x plus 2 times x minus 5. In this next one, I can see that I do in fact have two precise x-intercepts. And something that is unique about this is that at this x-intercept, it went from increasing to decreasing at that point. What that tells me with this graph is that this is a double root. Anytime you have your graph changing direction, changing rate of change, we call that a double root if it just touches at that point and changes its direction. So for this particular cubic function, our roots are going to be x equals -4, and we would call that a double root. And x equals 1. The factored form for this cubic is going to be written as x plus 4 times x plus 4, it has to appear twice since it's a double root, times x minus 1. Now, we could write this as the quantity x plus 4 squared times x minus 1, and it would still be considered to be factored form. In our third graph, what we see here is f of x equals x cubed, but I only see one x-intercept. Well, I can write f of x equals x cubed as f of x equals x times x times x. That tells me I have three factors of x. And because its x-intercept is at 0, I'm going to say that I have 0, x equals 0 as a root, but instead of a double root, it becomes a triple root. So if you have a curve moving along like this, you can consider it to have a triple root if the graph is going through the x-axis like this. It's going to be an odd number of roots when the curve continues on with a slightly different rate of change. And our last one is given to us here in factored form. Well, not complete factored form. Well, it's factored form in terms of real numbers. But I think what we're going to find is we're going to have some additional roots because it's not changing its shape at that point. So we know that x minus 3 is going to be a root. And I can take these factors here to find my roots, and it will indicate that negative 3 is in fact a root. If I take x plus 3 and set it equal to 0, well, x is going to have to be negative 3 in order for that to work. So that x-intercept is a root. Now for my other roots, I'm going to have to take x squared plus 4 and set it equal to 0. I'm going to subtract 4 from each side. So now I have x squared equals negative 4. Well, when I undo the squared by taking the square root, I end up with x equals, the negative inside the square root tells me it's going to be an I. The square root of 4 is 2, and because we're solving, we have two answers, a positive 2i and a negative 2i. And that's because 2 times 2 is a positive 4. Negative 2 times negative 2 is also a positive 4. And I could write these roots separately as x equals 2i and x equals negative 2i. Now, if you're wondering how I would write this in that complete factored form where I would be able to see all three roots, it would look something like this. We're going to have the x plus 3, like the original function had. But then I'm going to have two more factors. Now remember I said it's the opposite of the root. So x, the opposite of 2i is going to be minus 2i, and the opposite of negative 2i will be plus 2i. And that would be the fully complete factored form of p of x equals x plus 3 times x squared plus 4. And this concludes our video on finding the roots of cubic functions.